G'day viewers, well, just doing a quick load test in this Edecoa inverter. I ran some transformers, some mods, and it did it quite well. I loaded it up to 2400 watts, 10 amps, but this is my limitation. 80 amp loaded cable that's 2 meters long is nowhere near adequate for 300 amps that this thing needs to pull. No way. I got this battery. I put half a cup of Epsom salts in each of the cells. It now has a higher float voltage now. It's revived it better, but it's only a 250 coil cranking amp battery as opposed to a 900 coil cranking amp battery. It's kind of old, this one. Not designed for deep cycle use. I'm just using it for testing things like this. And I've got a parallel to 50 amp cable, just keeping the voltage up to charge it. That's what that's doing. I laid the 50 amps. I did have my Edecoa connected to here directly, but because this cable's so long, I only rated to 80 amps. It don't work on this inverter. The voltage drops like a sack of shit. Goes to about 10 volts and it cuts off. Although it did persist down to 9.7 volts, had dropped down that low, and the voltage dropped down to 215 volts AC. It isn't actually too bad. It actually maintains a good mains voltage under the voltage drop in the primary, the DC side, which is pretty good. With these inverters are short, probably at least a foot long of this grade cable. No longer than that. This grade cable is a must to pull 2400 watts from this inverter. Short, thick gauge cables are an absolute must. I already knew that, but I'm just doing tests with this thing. See what its limitations are. I did run a stick welder with it. I welded about a couple of little tack welds and this inverter cut out. It made kind of a buzzing sound like it was overloaded, but it had overloaded on the screen, so I turned it off quickly just in case it yeah, it didn't like running a welder. It did run it though, so that's all I wanted to do. It proves it actually does. It can support some inductive load, so 10 amps, but the welder was a 15 amp appliance anyway, so I don't blame it for cutting out and shutting down. It's not made for a 15 amp load, but it did it. But not for very long. It didn't like it. But that does more than this one here does. So it's definitely rated to 2.5 kilowatts. I haven't ran it long enough for the fans to come on. When I was testing it, the hottest it ever got was about 37 degrees Celsius. And the fans never come on yet. I think it gets to about 45 or something, or so around then, and the fans start coming on. But this is just a test. This is only temporary, this cable. I'm not going to have this cable on it all the time to run it normally. I'm going to set up some more, make up some more of this, like this short, heavy gauge cable for it. And I'll work on this, probably put it in the, maybe if I'll upgrade it with a mesh tray. I'm thinking about it, but I like this in it because it's got the it'll solar regulate with a solar charger, and it's got the remote inside, which gives me all the voltage readings and everything. That's what I really like about that one here. But if the power does actually go off and I need to run air fryers or boil the kettle, this is what it's for. I'll just get some short cables and I got 2 meters of this stuff, so it's good. Got some spare. I'll make up some more of these short cables and just set it here. I'll make a stand for it and put it here, and I can yeah, I've got a good 10 amp inverter. One more test I want to do. I can't turn my hi-fi system or anything on. As soon as I turn this on, well, that's all plugged in, but as soon as I turn this on, the inrush from the transformers in this trips out my mesh tray. So this thing pulls a lot of inrush when it turns on. I'm going to get an extension cord and just test it on Edecoa, see what that does, how it reacts to the inrush on that. It did run my MIG rotor though. My MIG rotor has about 30 amps inrush, and the Edecoa attempted to soft start that, but it did not like it at all. It did charge it a little bit with the halfway through the inrush. It charged the power supply side of the MIG welder, then it shut down. It did try to do it though, so that's pretty promising. I'm going to hook up this cord to the inverter, but probably been an inverter over here actually. 12.8 volts. Yeah, well, my cable is giving some drop there. That cable is inadequate. That's to be expected. You have to wait about 5 seconds for this to stop flashing, and it starts up and turns on. Should be able to turn this on. No. Ooh. Oh my god. Yes. Okay, that worked. It did turn on. Okay, the first bit of inrush. Now it turns on. There you go. I couldn't turn this thing on at all. The inrush was so bad. And now the first time it actually chipped that out. The second time it didn't, because I had to charge up its capacitors. Man, this thing has some inrush. Turns on. Nice. I think it attempts to soft start it. Because of the inrush, there's inductive loads. This does soft start, but not as much as my Mistray one does. So this is actually a bit of a, it does tolerate inrush better than my Mistray inverter does, which is nice. That's good. I'll turn the AM radio on. We'll see what the interference is like. Any noise, so to speak. Sounds pretty good. A lot of cheap inverters will fire through your cords and mess up your AM radio signal, but this one's pretty good. Better on par with my Mistray.
Riverland, partly cloudy tonight, chance of early morning.
That's good.
Partly cloudy day tomorrow. Top of 22 for Redmark. Looking ahead to
0.8 amps. At 245 volt, 247 volt, 0.8 amps. Yeah, here's a higher voltage, this inverter. This only puts it at 240.
6, currently in Mildura, 18.
Another day's almost done. On the Calder or South, Murray or Darling.
Low noise. That's good. Low noise. That's what I'm looking for. Love their songs. There we go, we've got low noise. That's what I was chasing. Anyway, let's do an off-grid video upload on my computer. Take note, that's not in the CPS as well. That also has a little bit of inrush added with it, the NAD. But it actually started this up, second time around. Yeah, not even getting warm, 22 degrees Celsius. There we go. But yeah, it didn't run the heater because of that cable. That cable's got too much losses in it. We ran the heater alright for about 3 seconds and that cable just sags like a bag of shit. That cable just has too much drop in it. Not rated at all. Anyway. Wait for me to get a monitor to respond. Anyway, that'll be enough for now. Thanks for watching.